Okay, so let's have a look at compass bearings. Now, so over here, right in the middle, we've got our compass, and we're going to be doing a lot of these ones, and we're going to be using this all the time. So I really need you guys to be familiar with this. Now, the way I want you to think about compass bearings is think about it as two things. We have the North King and we have the South King. Okay, now these two are very important when it comes to compass bearings. And the way I want you to think about it, and actually the way we measure the angles is like this. Pretend you're at the North King's territory and he's given you a message and he's asked you to send the message to wherever. Now, what would happen is once you get the message, you're going to go away from the North King. And the same thing is going to happen with the South King. If you're in the South King's territory and he was to give you a message to deliver, you're going to be going away from the South King. Now, when you go away, you only have two directions you can go. You can either go to the east side or you can also go to the west side. So let's just write down what I just said. Okay, so now let's have a look at this example here. So O is my starting point, so where I am at the moment, and I'm going to go to the point A. So now let's have a look. Am I in the North King's territory or am I in the South King's territory? And just because it's in the upper half, it has to be the North King's territory. So the way we would label it is this is so far it's going to be north. Now, remember how we said when we get a message, we're going to be going away from the North King. So therefore, the angle that I need to find out is this one over here. So I'm just going to call, let's say, this, for example, this was 40 degrees. So now, remember, I'm on the north side. I'm going 40 degrees away. And now I can only go either east or west. And clearly we can see that we're going towards the east. So now the compass bearing becomes north 40 degrees to the east. Okay, let's have a look at the next one. So again, I'm starting from O and I got to go to B. And now I want to find the compass bearing. So again, is it on the north side or on the south side? And we can see that it's clearly on the south side. So we know that it's going to be south. And remember, when we are on the south side, we're getting the message from the South King and we have to go away. So I ultimately need this angle right there because I'm going away. And now if I said that was 15 degrees, the angle that's going away. So far we know it's south 15 degrees. And now am I going to the east or to the west side? I'm going to the east side. So it's going to be south 15 degrees to the east. And that's our compass bearing for B. All right, next example. So I want to go from O and I want to find the compass bearing of C. So first thing, is it on the north side or on the south side? We can clearly tell that it's on the south side. Now remember, we have to measure the angle that's going away from south. If you notice, the angle that they've given us is 30, but that's not going away from south, is it? That's actually headed towards south. Now, if you don't think of it like that, that's fine. Just think about it as, hey, where's the angle that's going away from south? Clearly, it's missing. So now we have to solve for the missing angle. Now, if you guys remember, every single quadrant is made up of 90 degrees. 90, 90, 90, 90. And that's going to make up the total compass of 360. Now, since this quadrant is no different and it is going to be 90 degrees as well, how would I work out that missing angle there, theta? Well, that's just going to be 90 minus the 30. So the quadrant's 90, I'm getting rid of the 30 degrees that I don't need to find theta, which is what I do need. Because theta is the angle that's going away from south. So that's the only thing that I'm interested in, to find out that angle. So now that we've found the angle, that's going to give us 60 degrees. And now, am I going to the east or to the west? I'm going to the west because it's on the west side. And that's going to be our compass bearing for point C. All right, so now we're going from O to D. So nothing different. Am I on the north side or on the south side? I'm on the north side, so we know this is going to have to be north. Now, the angle that I need is the angle that's going away from north. So I need to work out this angle right there. Now, because we don't have it, I need to work it out. And let's just call that theta. Okay, so remember in the previous example, every single quadrant was made up of 90 degrees. So to find that missing angle there, I'm just going to do 90 minus the 70. And that's the angle that I'm after. So we're going to get 20 degrees. And now, east side or west side? I'm on the west side. So north 20 degrees to the west. So now on to example 1. Find the compass bearing from O of the points A, B, and C. Now I want you guys to pause the video, try these questions on your own, test yourself, and then play the video back and then check your answers. Okay, so from O to A, we're trying to find the compass bearing. First of all, the point A, is it on the north side or on the south side? Clearly it's on the north side, so we're going to say that's going to be north. And the angle that we need is the one that's going away from north. So I'm interested in that angle right there. And for this example, I have that angle, which is 30. So it's going to be 30 degrees. And now am I on the east side or the west side? I am clearly on the east side. And that's going to be the compass bearing for A. Now let's have a look at B. So B is on the south side and I need the angle that's going away. So south side, the angle that's going away. Now clearly that's missing, but what I do have is the 68 degrees right there. So now how am I going to find this missing angle over here, the one that I actually need? Well, since every quadrant is made up of 90 degrees, I'm trying to get rid of the 68 to see what's left over. So that's going to be 90 take away the 68, which is equal to 12. So the angle that I'm interested in is 12 degrees, and am I on the east side or west side? I am on the east side. Now onto the compass bearing of C. That's on the south side. I'm going 20 degrees away because they gave that to me. And am I on the east side or west side? I am on the west side now. Okay, next example. Let's find the compass bearing of A. So we can see that I am on the south side and I need the angle that's going away. Now, because that's missing, we got to do 90 minus 49, which is going to equal to 41 degrees. So the angle that I'm after is 41 degrees and I am on the east side. Okay, so now on to B. The compass bearing of B, I'm on the south side again. Now I'm interested in the angle that's going away. And because that's missing, I gotta do 90 minus the 15, which is 75 degrees. So my angle is going to be 75 degrees and I'm on the west side. So that's my compass bearing right there. What about for point C? Well, I'm on the north side, clearly, and I need to find the angle that's going away from north. Do you notice how this 83 degrees, it's going towards north? I don't want that. I want the angle that's going away from north. So that's just going to be 90 minus the 83, which gives us 7 degrees. So it's going to be north, 7 degrees to the west. Okay, so now let's have a look at another type of compass bearing that comes up often. And that's the one that splits exactly in half between northeast, southeast, southwest, and northwest. Now, what happens when it splits it exactly in half? Well, they don't always necessarily write down the angle there. But because it splits it in half, if we know that the entire quadrant is 90 degrees, halfway would be 45 degrees, and that'll be 45 degrees as well. So a way you could actually write the compass bearing of point A would be north 45 degrees to the east. Now, because it's exactly halfway, most textbooks and a way of asking a question that would always give it as just northeast. So they just skip writing the 45 degrees there. But just because the 45 degrees isn't there, so what I mean is if they just give you northeast and there's no angle in between, don't panic. It just means that it's 45 degrees, exactly halfway between north and east. Now let's have a look at point B. Let's say this angle there was 45 degrees as well. Automatically we have to know that because that's exactly in half, as in half of 90, this is now going to be southeast. What about with point C? For example, if I didn't give you any angles and I said this is southwest, that should tell you that in between here would be 45 degrees and this will also be 45 degrees. And the same thing goes with point D. That's going to be northwest. So we know that that's going to be 45 degrees and that's also going to be 45 degrees. Okay, so now let's have a look at a worded problem. Example number 1, Mary walked on a bearing of south 65 degrees west for 3.4 kilometers. Find how far west she has traveled correct to one decimal place. Now, in the question, as soon as you see the words like walked on a bearing of, and then they'll give you the compass bearing, straight away, draw your compass. Straight away, the first thing you should always do in these questions, draw your compass. And now let's see what's happening. Mary walked on a bearing of south 65 degrees to the west. So let's say Mary started over here and she walked on a bearing of south. So now we know that we're going to be somewhere here on the South Kings territory, right? And she's going 65 degrees to the west direction. So she's going to be somewhere over here now. So that's where she walked to. So let's analyze the compass bearing a little bit. She's in the direction of south. She's going 65 degrees away from south. So therefore, we know that this angle there has to be 65 degrees. And she's traveling to the west direction. So now I know that that angle right there is going to be 65 degrees. And she walked on this bearing for 3.4 kilometers. So now I know that this distance is going to be 3.4 kilometers. The question's asking, find how far west she has traveled. Now, if you guys remember, west was all in this direction over here. All of this side all of that would be the west side, right? So since all of that was the west side, I have to find how far west did she travel. So I got to find that blue line right there because that blue line indicates that that's in the west direction from where she started. So now if we're trying to find what that length there is, you can just straight away just call that x or some variable, whatever you like, a, b, c, x, y, z. And now look at what you notice. It just made a right angle triangle right there. So now, if your diagram looks a little bit messy, that's fine. Redraw the parts that you actually need. And the parts that I need is that right angle triangle right there. So let's go ahead and do that. And the information that we do know is that that's 3.4 kilometers. We know that this angle over here is 65 degrees, and we're trying to work out the value of x. Now, since this is a right angle triangle, two things should come into your mind whenever you see a right angle triangle. First of all is Pythagoras theorem. So c squared is equal to a squared plus b squared. And the second thing should be SOHCAHTOA. And that's basically the trigonometric ratios when dealing with finding a side or finding an angle. Now, I'm not interested in Pythagoras because I don't have the other side over here. If I did, then yeah, sure, go ahead because we'll just be finding the other side. But since I don't have that and I've got an angle included over here, I'm going to be using the trig ratios, so sine, cos, or tan. Now, if you guys remember with SOHCAHTOA, sine theta is equal to the opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta equals to opposite over the adjacent. Now, how do you know which one's which, like which one's opposite, which one's adjacent, and which one's hypotenuse? Well, let's start off with hypotenuse. Hypotenuse will always be the fixed one, which means that's always going to be opposite the right angle right there. So that would never change. But what will change is the opposite and the adjacent side. Now, how do we figure that out? Well, everything is in relation to the angle. So what that means is wherever my angle is, the opposite side will just be opposite that angle. So if I have a look at this 65 degrees right there, this side that's directly opposite the angle would be my opposite side. So therefore, what would this one right there be? That would be the adjacent side. And adjacent just means next to or side by side. Now, don't get confused with the adjacent side and the hypotenuse. Remember, the hypotenuse we said was always fixed. So that will never change. So that's the way you can kind of think about it to not get confused between adjacent side and the hypotenuse side. Okay, now let's figure out which ratio to use. So according to the angle, I have the opposite side over here. So that's like the opposite side. And I've got 3.4, and we said that was the hypotenuse. So opposite and hypotenuse, that could only be sine. So sine of 65 would equal to x over 3.4. And now we're just solving for x, so multiply the 3.4 to the other side. So therefore, x will equal to 3.4 multiplied by sine of 65. Now, a common mistake that students will do is that they'll write it like this in their calculators. Okay, since I'm timesing by 3.4, they'll go sine of 65 multiplied by 3.4. They'll close the bracket and then they'll give it, and then that'll give their answer. Now, why is that wrong? Is because you've just gone ahead and multiplied the angle by 3.4. Whereas what we're trying to do is we're trying to multiply sine of the angle by 3.4. So that's being multiplied. The whole thing there is being multiplied by 3.4. So don't do this. Don't ever get confused with that. We're not multiplying the angle, rather we're multiplying the sine of the angle. So x will equal to 3.081446476 and so on and so on. But because we only want it to one decimal place, x will equal to 3.1 kilometers. And that's how far west Mary has traveled.